So we learned a little about Lewis structures for individual atoms. So just as a refresher, we know that we're going to put a dot around each element representing the number of valence electrons. So hydrogen, we put 1 dot yesterday. Aluminum has 3 valence electrons. Oxygen has 6, so 1, 2, 3, 4, kind of like the 4 corners. And then we start pairing up. Keep Hund's rule in mind. And then we get to neon, which has 8 electrons, and so it's got a full valence shell. So we talk about rules like the duet rule and the octet rule and the exceptions for metals rule. Hydrogen tries to get a pair of electrons. Aluminum, there's the duet rule. Aluminum is a metal, so what it does is it just pairs up those 3 unpaired electrons. So aluminum's happy if it has 6 bonds. Now, keep in mind that metals don't typically form covalent bonds. Usually the only time you see metals forming covalent bonds is if they're bonding with hydrogen, so you create a metal hydride. So if aluminum bonds with hydrogen, it's going to bond with 3 hydrogens so that it pairs up its 3 electrons. Oxygen has 6 electrons. It's got 2 full orbitals of electrons and then 2 half full orbitals. So oxygen's only going to form 2 bonds. And then neon, having a full valence shell, is not going to form any. So here's the examples of our octet rule. Here's the example of exceptions for metal rule, and then here's the duet rule. So let's advance and take a look at what happens when we start putting atoms together to create actual molecules. So on the back of your organizer that we started yesterday, you've got some information here, and my dots have gone through, sorry. So a Lewis dot structure shows all the valence electrons. Even though we're going to draw a line for a bond, those non-bonding electrons are going to be there. Typically, our angles are all going to be 90 degrees. Structural formulas drop the non-bonding electrons. So all you see is lines for bonds. So we'll get to all of these rules eventually, but first you want to, when you're looking at a molecule, if you want to figure out how many bonds each atom is going to need, so that kind of goes back to the unpaired electrons idea. The atom that requires the most bonds is typically going to be in the center, and then you're going to place atoms that only require 1 bond around the outside. They kind of act like an outer shell, so hydrogen and halogens are going to be outer shell electrons. Atoms, things like oxygen, carbon, and nitrogen, those are going to be more likely central atoms. And then you're going to pair up any unpaired electrons by forming a bond between 2 atoms. So we're going to stick with those 4 rules first. We'll come back to the other 3 a little bit later, but let's just do a bunch of examples. So switching papers here, we've got, start out something really simple like H2. What's the Lewis structure for H2 going to look like? Well, each hydrogen, and you don't have to actually draw this, but it sometimes helps to kind of visualize where things need to go. Each hydrogen has 1 electron. They need to form 1 bond. Well, when atoms form bonds, they share single electrons to make a pair. So what's going to happen? A hydrogen and a hydrogen are going to face each other, and you're going to get this bond like this. So I can draw that or this as the Lewis structure, and then this also is the structural formula. So Lewis structures can be the dots with the circles, but typically we're going to try and do Lewis structures where a bond represents a line. Now I can do something like water as well. Let's get a little more complicated, H2O. Again, I've got 2 hydrogens and I've got an oxygen. Oxygen has 6 valence electrons. Each hydrogen only has 1. So in order to make water, I can't bond the 2 hydrogens together because then oxygen is kind of left out. So hopefully you can kind of see that 1 bond is going to happen between hydrogen and that oxygen. 1 bond is going to happen between hydrogen and that other electron of oxygen. And so we're going to orient the atoms a little bit better so that you can see what's going to happen. You're going to get a bond here and you're going to get a bond here. So a Lewis structure for water is going to look like that because we're going to show those non-bonding pairs of electrons. A structural formula for water is going to look like that because we want to make it a little bit cleaner. So we're going to pull out those valence electrons. So Lewis structure versus structural formula. Okay. All right, let's go on. We'll just do a bunch more examples. If I want to make something like ammonia, NH3, okay, nitrogen has 5 valence electrons. Hydrogen each has 1. So it's a little bit like a puzzle. Can you see what's going to happen? The 3 hydrogens are going to have to go to each one of those nitrogen lone electrons to form a bond. So you're going to get nitrogen, hydrogen, hydrogen, hydrogen. There's your Lewis structure for ammonia. Okay, we're having trouble focusing. And then structural formula, all I'm going to do is remove that one pair of electrons, that non-bonding pair, and there's my structural formula. So they look very similar, but again, structural formulas are a little bit cleaner. All right, let's move on and do something else. How about SCl2? We'll go something very, very different. Okay, so sulfur, 1, 2, 3, 4, 5, 6 valence electrons. Each chlorine has 7 valence electrons. Okay, so if I put the 2 chlorines together, there's no place for sulfur. So what's going to happen? Sulfur's got to go in the middle, and it makes sense based upon our rules, right? The atom that needs the most bond is going to be your central atom. Halogens and hydrogen will always form the shell around the outside. You saw that it's true. Nitrogen's the central atom here. Oxygen's the central atom here. That's true in all of our examples. So I'm going to make sulfur my central atom. And then what needs to happen? Well, I only need a chlorine to bond with each of those individual electrons. And then I'm going to show chlorine's other 6 electrons. So there's my structural formula for SCl2. And then, I'm sorry, my Lewis structure. And then my structural formula is just a little bit cleaner because there are no electrons. All right, let's try another one. Off the cuff here, I'm having a hard time thinking about something. How about CH2Cl2? Okay, so chlorine has the 7. Again, you don't have to draw these individually if you don't need to. And then carbon, something new that we've seen, has 4. So carbon, no bonding pairs, so they're going to be, carbon's going to be our central atom. So carbon needs 4 bonds, whereas chlorine and hydrogen only need 1. So I can have 1 hydrogen here, 1 hydrogen there. I can have 1 chlorine here, and 1 chlorine there. Oops, running out of space. There we go. And then my structural formula. Oops, I rotated a little bit, but same thing. If I rotate this thing 90 degrees, it's going to be the same structure. Okay, so very simple single bonds showing how things are put together. You want to pair up unpaired electrons. What I'm going to do is just a couple more, give you a chance to practice. So I'm going to write them down, and then we'll pause and let you do a few, and we'll go through them together. So how about CH3OH? How about PBr3? And we'll do one more. OFI. All right, so won't you pause this and give it a shot, and then come back and check. All right, so hopefully you had a chance to work on these. So this one is a little complicated. Carbon needs 4 bonds. Each hydrogen which there's technically 4 of, and then an oxygen only needs 2 bonds. So it turns out that we don't have just one central atom. Here I made the other 2 a little bit easier, but we don't have just one central atom. If I bond all 4 hydrogens to this carbon, there's no place for oxygen. Okay, so the 2 that need the most bonds, hopefully it makes sense, are going to have to go together. So I've got carbon and oxygen with a bond. Okay, now I still need 1, 2, 3, 4 more bonds, and look at that, I got 4 hydrogens. So I can make my structure look like that. So hopefully that's what you came up with after a little bit of thought. PBr3 should be a little bit easier. Phosphorus needs the most bonds. It needs 3, so that's going to be your central atom. The 3 bromines are going to go around the outside. And I'm not doing structural formulas. I figure it's easy enough. All you have to do is remove those dots. So there's the Lewis structures. And then OFI, oxygen needs 6. The halogens each only need 1, so oxygen is going to be your central atom. You've got a fluorine to 1. You've got an iodine to the other. And there you go. So there's a couple problem sets that just do these single bonds that you can work on now. The next video we're going to take a look at actually introduces you to double and triple bonds, which are also possible. So we'll get to that in the next video.